Hello, and welcome to this third and final video to accompany the AMSP Further Maths Conference Student Use of Technology for Studying Matrices session. In this video, we're going to have a look at the use of GeoGebra and how students can use various different versions of GeoGebra to help them understand matrices. So, in the first of the two activities we're going to look at, they're going to look at a prepared file online to do with matrix transformations. There's the link to a file here, and it's in the handout that accompanies this session as well, and I'll go to that file now. Here's the file online, and I can press this button down here to see a full screen version of it. So the point of this activity is they're given a matrix up here, and they're given a blue triangle that they can move around, and the red triangle is the image of the blue triangle with the points labelled under the matrix. So the question is, are there any invariant points and are there any invariant lines? So here we've got a triangle, and you can probably see fairly quickly that the matrix is a rotation 90 degrees clockwise around the origin. You can see the matrix here. So wherever I move A to, it's not possible to put A in a position so that the image A' is in the same position, with one exception, which is the origin. Other than that, I can't put A anywhere and have it move to itself. I also can't move A anywhere, so A' sits on a straight line through the origin. So there aren't even any invariant lines here. If you contrast that to what would happen under the image of the matrix 0, 2, 2, 0, and I'm just changing the matrix here just by literally clicking into that box. I can see here now I've got a new transformation. Let's move these points a little, zoom out. Now, again, there's nowhere I can move A' to so that A2 so that A' is the same point apart from the origin. However, I can move A along a line so A' is also on that line. So the only invariant point is the origin, but you might be able to see if I put in the line y equals x here, wherever I sit A' along that line, A along that line, A' will be on there. There's also another invariant line along here. It's the line y equals negative x. Now again, if I sit A anywhere on this line, A' sits on that line too. So, going back to the question, the activity is students use this file to try and fill in this grid. Can they find a matrix such that the invariant points are either only the origin or there's a line of invariant points? And can they find any invariant lines? The points themselves don't need to be invariant, but the image needs to sit on the same line. The two examples we looked at here, 0, 1, negative 1, 0, only had the origin as an invariant point and had no invariant lines. The second example had only the origin as an invariant point and y equals x and y equals negative x as invariant lines. So the activity is to follow the link to this GeoGebra file and try exploring and find whether you can fill in any of these other boxes here. The second activity uses 3D GeoGebra. This is taken from the GeoGebra tasks on the MEI website. This is the GeoGebra task page on the MEI website. If you see down the bottom, some further maths tasks. In particular, we're going to look at the 3x3 matrices and transformations one. This is what the task looks like online. So, in this task, students start entering some things in either the 3D graphing calculator or the 3D view. So there's a few ways you can access this. If you've got a downloaded version of GeoGebra, you can just use that. Alternatively, students can either use this via the web or they can download the 3D app for their tablet or smartphone. We're going to use the 3D view on the web. So on this page, I'm not going to click Start Graphing. I'm going to click 3D Calculator down here. So the first thing to do is enter my matrix. So my matrix was M equals, and it's nested sets of curly brackets for matrix. So I've got -1, 0, 0, close those curly brackets, open a new set of curly brackets, 0, 1, 0, finally, comma, and a last set of curly brackets, 0, 0, 1. What to type in is on the worksheet. Type that in and get this matrix. I'm then going to add a cube to transform. Go over to the tools here, click on cube, click once on the origin and once on the point, 3, 0, 0, and I get this cube. Now I want to transform this cube by the matrix. I can't do that in one go, unfortunately. What I'm going to need to do is get a list of the faces and transform the faces. Slightly fiddly. You have to type in all of this text here, but if you're using it on the web, you can just copy that and paste it in. Now with that list F for the faces, I can use the command apply matrix, and I'm going to apply the matrix M to the object F, which is the list of faces, and there it is. Give that a slight spin and see it spinning, see it moving around. So the green is the image of the red under the matrix, and the great thing about this is students can start exploring changing some of these values and seeing what the image is. So back to the task. They're then asked to explore some other transformations and see if they can identify what's happening with the 3-dimensional transformations under the matrices. So there's a couple of activities that students can try using both the 2D and the 3D version of GeoGebra, and some worksheets or tasks that go along with those. I hope you enjoy using these with your students.